Now, the couple of formulas which you have to remember so that it will be easy for you to do the sums. The first one is if I find the derivative of a constant, which we say ddx of constant. Please note, constant is a term which is independent of any variable. It has variable, but to the power 0. Okay. So it's just a fixed term or a fixed number. That is what we call a constant. So if we find derivative of a constant, it is always equal to 0. And if we find derivative of x to the power n, we have done exponents if you remember, if in my previous sessions. So x to the power n is an exponent. So if we have to find the derivative of the x to the power n, then the formula says it can be equal to n into x to the power n minus 1. The power comes to the coefficient and then x's power gets decreased by 1. So ddx of x to the power n can be written as n into x to the power n minus 1. This is one formula, and ddx of constant is 0 is the other formula which you have to remember. There are some examples which I have given so that you can understand it. Let's find out the first example. What does it say? The position of a ball after time t minutes is given by the following function. So remember, the position of the object is given by a function. The function is a function of t. What is t? T refers to the time, and pt refers to the position of the object after a given time t. So the position of a ball after time t minutes is given by the following function. The function is pt is equal to 5t square minus 10t plus 4. So this is an expression given which indicates the position of the ball after time t minutes. Okay. Now there are a couple of questions given for us to do. Number one, is the ball moving upward or downward at t is equal to 3 minutes? Is the ball moving upward or downward at t is equal to 3 minutes? How do we do? Well, we need to calculate the velocity from here because this is the position expression which is given to us. When we find out the derivative of pt with respect to t, we will get the velocity. Now, in that velocity, if we substitute t is equal to t and find out what is the value of the velocity, if the value of the velocity is positive, then the body is moving upward. If the value of the velocity at t is equal to 3 is negative, then the body is moving downward. That's the way how we do it. So let's try and find out where will be the body moving, upward or downward at t is equal to 3 minutes. So we are given pt is equal to pt is equal to 5t square minus 10t plus 4. So this is the expression which indicates position of the body. Now we have to find out the velocity. So the velocity v will be equal to dp upon dt or dp by dt, which means we will find out the derivative of this entire expression 5t square minus 10t plus 4. Okay, now derivative says it can be the the ddt can be attached to all the terms. So we can write ddt of 5t square then minus ddt of 10t and plus ddt of 4. Okay. So ddt of 5t square. Now we are going to apply this formula ddx of x to the power n. In this case, there's one more formula. In case if we have ddx of k into x to the power n, where k is a constant, then we write k into ddx of x to the power n. So the constant moves as a coefficient and the derivative is only done for the variable. In this case, we are doing the derivative with respect to t. We have got 5t square. So 5 is a constant which is going to move out of the bracket and remain as a coefficient, and the derivative d dt will only be attached to t square. Okay. So we will get 5 into d dt of t square. Okay. Here also we will get 10 into d dt of t plus. Now, d dt of 4, what is 4? 4 is a constant, it does not have any t, it does not have any variable attached. So, the constant's derivative is always equal to 0. So, d dt of 4 will be equal to 0. Okay. Now, we are left with only these two terms. So, 5 into what is d dt of t square? We are going to apply d dx of x to the power n. Rule says that the power comes to the coefficient and then we will write x to the power. From n we have to subtract 1. So, here we have t square. T square means when I do the derivative, I will get 2, 2 will come to the coefficient, and then t to the power 2 minus 1. T to the power 2 minus 1 will give me only t. Okay. So, that is my derivative done. d dt of t square can be written as 2 into t to the power 2 minus 1. In other words, it is 2t minus again 10 into d dt of t will be equal to 1. Okay. d dt of t, how it is 1? Because the power is 1, t to the power 1, 1 is going to come to the coefficient, and then we will write t to the power 1 minus 1, which will make it t to the power 0. And anything to the power 0 is 1. We have seen in our exponents class. Okay. That was a formula. Anything to the power 0 is 1. So, d dt of t is 1 and this is 0. So, finally, we are going to get 10t minus 10. This is the velocity. Okay. Now, if we calculate the velocity at t is equal to 3, then what will be our answer? So, velocity at t is equal to 3 will give us 10 into 3 minus 10, which is equal to 30 minus 10, which is equal to 20. 20 is positive, so we can write it greater than 0. It is positive. So, since the velocity at time t is equal to 3 has come out to be positive, therefore, we can very safely conclude that the ball is moving upward at t is equal to 3 minutes. So, that is what we are going to write. Therefore, the ball is moving upward at t is equal to 3 minutes. Okay. So, we have concluded that the ball is moving upward at t is equal to 3 minutes. How did we conclude? First, we found out the velocity, and the velocity is given by 10t minus 10. Okay. Now, in this velocity, we have applied the value t is equal to 3, and on calculation we are getting velocity is equal to 20. Since 20 is a positive number, so that indicates that the ball will be moving upward at the time t. Okay. So, that is your first part of the question. Let us come to the second part of the question. The second part of the question says, will the ball ever stop moving? That is a question. There is a positional expression which is given to you. You have to find out the velocity, and then the next part of the question says, will the ball ever stop moving? Now, that is only possible when the velocity becomes 0. When the velocity of a moving body becomes 0, obviously the body is stopping. So, let us find out whether it will stop or not, and if it does stop, then at what time will it stop? Okay. So, I am not going to erase the complete steps that I have done. I will just skip the velocity part. We know that v is equal to 10t minus 10, that we have calculated from here, 5t square minus 10t plus 4 by doing the derivative of pt with respect to t. So, I am keeping it here because we will be using it, we need to use it. So, since I am doing number b, since velocity is equal to 10t minus 10. Therefore, at t is equal to 1, we get v is equal to 10 into 1 minus 10. 10 into 1 is 10 minus 10, which is equal to 0. So, we are getting velocity is equal to 0. Okay. When t is equal to 1, then we are getting the velocity is equal to 0. So, the question says, will the ball ever stop moving? Answer is yes, it will stop moving at t is equal to 1 minute. So, that's what we are going to write. Therefore, the ball will stop moving at t is equal to 1 minute. That's the answer. Part A, we got to see that the ball was moving upward at t is equal to 3 minutes. Part B, we found out that the ball will stop moving at t is equal to 1 minute. How do we know? Because the velocity came out to be 0. So, when the velocity of the moving body is 0, obviously the body is going to stop. So, the ball is going to stop at t is equal to 1 minute. That's the way how you can do the sum. Okay. So, we'll see another sum. The next question. So, the next question says, okay, the next question says, suppose the amount of water a reservoir can hold at t minutes is given by the function v is equal to 3t cube minus t square minus 40t plus 40. That's an expression. This is the expression given for the volume. Suppose the amount of water a reservoir can hold at t minutes is given by the function v is equal to 3t cube minus t square minus 40t plus 40. We are asked to calculate the following. What is that? Is the volume of water in the reservoir increasing or decreasing at t is equal to 2 minutes? Now, this actually comes of a different topic on increasing and decreasing function, which I am going to show you after some time when I finish increasing and decreasing function. Okay. So, right now we'll bypass it. We'll come back again to this particular slide. Okay. So, we explained about what is the physical interpretation of a derivative. Physical interpretation of a derivative says that the instantaneous rate of change with respect to a given time or a given point is what is called the derivative. Okay. Now, what is the geometrical interpretation of derivative? Let's find out that. We know that every function can be represented by a diagram in the graph paper, or we can say that that's a geometrical interpretation or the geometrical representation of the curve. Okay. So, if we are talking about derivative at a particular point in a given curve, then we actually mean to say the slope, SLOP slope, okay, or it is also called gradient sometimes. The slope of the given curve at that given point is what is called derivative. Geometrically, derivative of a function can be defined as the slope of the graph of the function, or more precisely as the slope of the tangent line at a given point. So, say for example, we have a given function. That function, when I plot in a graph paper, I get in this shape. Can you see this red curve? So, this is the shape of the function. Okay. Now, suppose we are asked to find out what is the derivative at the point P. So, what we have to do is we have to draw a tangent to the curve through the point P. Tangent is a straight line which touches a given curve at only one point. So, this green color line is the tangent to the curve, which is the red color curve at the point P, because it is touching the curve only at the point P. Okay. Now, the slope of this particular tangent will give me the derivative. What is slope? Slope is tan of the angle, trigonometric values, tan theta. So, if I say this angle is beta, like here you can see this angle is beta. So, tan beta will be the slope of this green line. tangent of the angle made by the line with the positive direction of the x-axis is called the slope. Slope of a given straight line is the tangent of the angle made by the line with the positive direction of the x-axis. So if I have a curve and I'm asked to find the derivative at a particular point, then the first thing is I need to draw a tangent to the curve through the point and then find out what is the angle made by the tangent with the positive direction of x-axis, and the tangent value or the tan of the value of the angle. If the angle is theta, we say tan theta. In this case, it is beta. So tan beta will be the value of the slope of the line, and that will also be equivalent to the derivative of the given function at the given point. So I repeat, geometrically, derivative of a function can be defined as the slope of the graph of the function, or more precisely as the slope of the tangent line at a point on the curve. So this is the definition geometrically of what we say derivative. It is nothing but the slope of a tangent that touches the curve at a given point. Okay, so that is what is your geometrical interpretation of derivative. So we now saw what is physical interpretation of derivative. Physical interpretation of derivative is rate of change. Okay, with respect to point, with respect to time, that is what is derivative. Then we also saw what is the geometrical interpretation of derivative. Geometrical interpretation of derivative is the slope of the tangent line to a given curve through the given point. That is what is the geometrical interpretation. Coming to the list of formulas, it's important for all of us to remember certain basic formula in order to do the sums related to the derivative. So the most common formula that you will be coming across, I have listed them. First, we have already done ddx of any constant k can be taken as 0. ddx of k is 0. Then we have ddx of k into fx. This also I have already shown you in the previous slide. ddx of k into fx, k is a constant, okay, but it is the coefficient. So the coefficient goes outside ddx. ddx is only attached to fx, as because the function has got the variable. Okay. Then we have ddx of x to the power n, not here, it will be power n, x to the power n, can be written as n into x to the power n minus 1. Then there are 4 formulas which we say sum, difference, product and quotient formula. So suppose if we have sum of 2 functions, f is a function, g is a function. So f plus g will also be a function. Now what will be the derivative of the sum of the 2 functions, f plus g? In fact, it is equivalent to finding derivative of f, then finding derivative of g, and then adding up. So ddx of f plus ddx of g gives you the ddx of f plus g. Same goes with difference. If you are finding ddx of f minus g, we have to find ddx of f, then minus ddx of g, that will give us the answer. Now, if you have product is slightly different. If you have product f into g and you are asked to find out the ddx, then it is just unlike sum and difference. It is not just ddx of f and into ddx of g. No, it has a rule which you have to remember. So normally, if I say f as the first function, g as the second function, then the product rule of differentiation says first function into derivative of the second function plus second function into derivative of the first function. So it's like cross. Okay. So first function means f into derivative of the second, ddx of g, then plus sign. Again, second function, which is g, into derivative of the first, which is ddx of f. So f into ddx of g plus g into ddx of f. That's the rule for the derivative of product of 2 functions. Then we go to quotient. Okay, the quotient of 2 functions. Now here, if I have to find ddx of f upon g, then we find out just almost similar to the product rule. So here we first write second function into derivative of the first, and then the sign given is minus. Here the sign was plus. Second function into derivative of the first minus first function into derivative of the second. Then whole thing has to be divided by second function's square, g square. I repeat, if we are finding ddx of f upon g, it is g into d dx of f minus f into d dx of g, whole thing divided by g square. So these are the set of formulas which we'll keep using again and again as and when we come across sums, and you all need to remember this formula. Okay.